All right, good morning, good afternoon, good evening, wherever you are. Welcome to today's Autodesk Community Conversation. Next, Martin. And while we're waiting for people to join, why don't everybody just post where they're joining us from? It's kind of a fun little thing to kind of get the global distribution of where everybody's joining from. Started if everybody's shy. Oh, hey, Bob Bell. Bob, I didn't know you were in Portland. I left Portland for Bend and you go to Portland. What is this, musical chairs? So awesome to see you join us. I think I posted a photo of the two of us today. It's my 25th anniversary today. Welcome, Jason, Cedar Rapids, Iowa. I am hosting today. Kimberly had an emergency that she had to tend to. So you guys are stuck with me today. And we got Rob Bellman from Eugene. We get Oregon dominating. Mr. Smoker, West County, Sonoma. Naranjan from Qatar. Welcome. You definitely get the award for the furthest in this session so far. So. And Cape Girardeau, so Missouri, or Mississippi. I could be totally wrong. I just know it's along the Mississippi River. Yeah, Missouri. Okay. Welcome, Paul. All right, let's get this show started, shall we? I'm going to paste in a link. We're going to handle all the questions in Slido, and so if you want your question answered by the panel today, make sure to put it in Slidos. I'll give you a URL as well. And again, welcome today. Today's community conversation. Community conversations are fun, nice events. They're more personal. You have interactions with the speakers. We have many different sessions on the calendar, from Revit to Dynamo to Fusion 360, all sorts of stuff, and you can host your own. So it's all different levels. And today we have the Revit MEP product roadmap, Ask Me Anything, with the panelist Martin Schmid. He's the Autodesk product line manager. So I'm your host, Shaan Hurley. David Smoker's in the background holding down the fort. And let's go to the next slide, please. This is the fun one from lawyers. This basically says if we talk about anything forward-leading in any of this conversation or questions, that you make any purchasing decisions based on the product as it ships today. That's all it is, pretty simple statement. We do our best to talk about future, but we can't be held to dates or actually delivering on those until there's more work on the back end. So next, please. Anyone can enable the live transcription of audio in 11 languages. And you do that by going into the meeting controls, select more options, and then turn on live captions. That's French, Spanish, German. There's a whole bunch of languages there: Chinese, Japanese, Ukrainian. So if you need that, that is there for translating the audio. Make sure to submit your questions in Slido, and we'll be watching those and jump into those. It's nice to see Bob threw one in there. I expect him to be very active. This session will be recorded. The recording will be posted on the community conversations page, and we'll also make announcements everywhere. We'll also take all the questions and do a wrap up of all 5 of these excellent AEC AMAs. And the questions were answered, as well as any of the questions that were left over and were answered by the team following the event. So a lot of good stuff in here. It's been a good long week. Next, please. I am Shaan Hurley, Autodesk Community Engagement Manager. I am a geeky technologist located in chilly but sunny Bend, Oregon. Over to you, Martin.
All right, thank you, Shaan. So I'm Martin Schmid. As Shaan said, I'm one of the product line managers here at Autodesk. I tend to focus on our electrical design capabilities, as well as our mechanical detailing capabilities. And then my colleague Ian Malloy, who focuses more on mechanical systems analysis side of things, is is out on sabbatical actually at present. So I'll do my best to answer any questions. There might be some questions that I would need to defer, and we'll do our best to get answers to those in follow-up collateral after this event. So with that, I'll kind of jump right into kind of the first thing that we have to share, and some of you have already started seeing this. In fact, I started seeing some comments come through on our new public roadmap. So I believe David will share the link to that if he hasn't already. But basically, we've kind of re-envisioned the way that we're sharing our information more publicly. And you can see kind of across the top, we have this across different kind of timescales, if you will. So things that are currently in progress, things that you could expect to see sooner rather than later. And then a tab for things that are up next, things that we kind of believe we're more ready to start jumping into as soon as some of the in-progress stuff wraps up. And then later represents things that are kind of on our radar, but a bit further out. And then of course there's launched, which are things that just recently came out within the last 1 or 2 releases, just to kind of keep a fresh eye on those. And then the last one is not now, and those are things that we get common inquiries, common questions about. But unfortunately, there are things that, and there's descriptions in those as to why those are infeasible to invest in, at least at the present time. So please take a look at the public roadmap and dive into that. A couple other things, in fact, I wanted to open it actually up live, is when you drill into it, you will see, like if you select on something, you'll see something with a bit more detailed information under there. But then there's an opportunity for you to provide additional feedback. We always appreciate as much as feedback as we can get, so you could rank like how important this is to you, but then also provide other insights or feedback or commentary or whatever. And then if you include your email address there, then if you indicate so, we can also potentially use you as a reference for any further research and those sorts of things, because it's always hard to tell exactly what's meant sometimes from a single comment and those sorts of things. So we're throughout our projects and our research and development activities and so forth, we have ongoing conversation with our users and stakeholders and so forth to ensure that we're meeting the mark with regard to what we're working on. So please take advantage of that. All right, so with that, and then I also wanted to share a few slides just to kind of set the backdrop of what we're investing in, why we're investing in it, and the direction that generally that we're going. And also I'll have you note, I've put the QR code for the Slido up in the upper right-hand corner. So if something sparks a question, feel free to snap that and then put your question in. But that way it's always available throughout kind of these first few slides. So generally our remit within the MEP space and our mission and vision is steeped in delivering better buildings ultimately through integrated design analysis, coordination, and fabrication processes. And so that's kind of represented here by seeing, all the data related to the building in kind of one common environment related to our broader Autodesk Cloud strategy to be able to connect, different applications, different types of workflows, different stakeholders in an integrated way. And so you might wonder, well, what do you mean by integrated? So when we're looking at this, we're looking at it in terms of not just MEP, but certainly how mechanical and electrical could better coordinate and interact with each other, but also how that lays way into how architects and structural engineers feed into kind of the process, right? Obviously the architectural model, the data from the architecture, the glazing, the walls, so on and so forth, areas, all those feed into early stage design. And so it's a major part of the MEP workflow is how we could better work with the architectural model. And then further to that integration, it's across all these stages, right? We have stakeholders from very early MEP design stages for design and analysis. So these are the engineers that are doing, takeoffs and preliminary analysis and those sorts of things, which is all data that then ultimately feeds into kind of the next stage of coordination and documentation, where Revit historically has kind of had its bread and butter of creating a 3D model, generating drawings, coordinated drawings and documentation from that, and then leading out into more and more higher fidelity models to support detailing and fabrication at the other end of the spectrum, where we have estimators and detailers and contractors actually utilizing the model for quantity takeoff and fabrication and prefabrication, installation, assembly, and all those sorts of things. So it's really our task and our view around, how do we best connect a thread through all these different stages, all these different stakeholders in ways that supports better communication and iteration, because again, we've been very focused on early stage design, the mechanical systems analysis that came out a few years ago, the Revit electrical systems analysis functionality that came out in the 2023 release kind of feeds into that as well, because we see that as all setting up the basis of design that really feeds everything else downstream. And the more that we can connect this, ultimately, the more that we can automate and those sorts of things, deliver better quality across the stages to your consumers and customers ultimately. So another way to look at this then is, looking at those 3 stages, all feeding into kind of this common data repo, again, tied into our broader cloud strategy. So all stakeholders are participating, and that data evolves over time. So early stage design analysis is obviously kind of leveraging surfaces and areas and kind of conceptual information, and then elevating that stage by stage to more and more fidelity, more and more information as it evolves throughout the process. And so how do we connect all that? How do we retain information at different stages? How do we have the appropriate information available to each stakeholder in an easy way to consume, but then also contribute back into? So that's kind of the big backdrop there of ultimately what we're trying to do. So we're also typically thinking about, like, how do we communicate, some of the favorite things that we have kind of recently come out and what's coming up to make sure that you're aware of. And this is one of those that it's like, not a big thing from the standpoint of like a major new, capability, but it's one of those that it's, big quality of life thing of finally getting the ability to use the split with gap functionality across MEP elements of MEP segments, whether those are design elements or the fabrication elements. Being able to use that to, split an element and then be able to make modifications beyond that. So hopefully that's a very welcome addition to your arsenal in the 23.1 release. So that's one that was recently released. And then the next one, something that you could look forward to on the near horizon, is kind of tied into what I was speaking about with the new electrical analytical capability that came out in 2023. But this is kind of building upon that. So we don't just release one thing and walk away from it, hopefully in most cases. But what we're trying to do is have a more consistent contribution into each of the areas that we're focusing on over a sustained amount of time. So this is kind of representative of that, of having that new electrical analytical capabilities in the 23 release. And then in the upcoming release, we're planning on having some enhancements around that. So tying in now all the demand factor functionality into those analytical components, as well as some new capabilities that didn't exist previously that have kind of been a long-standing need on the electrical analytical distribution. And that's the ability to account for non-coincident loads, specifically like if you have, say, redundant pumps or redundant chillers or those sorts of things. So you could start defining that, yeah, I have all these elements connected in my distribution. These are my loads, what I would ultimately need to use for the sizing of that final feeder, that final branch circuit, but then on up through the distribution, starting to be able to look at the deducting that load automatically throughout the distribution in an intelligent way to appropriately size for that. So these are kind of along the vector of generally improving the electrical analytical information, being able to capture more of the design and analytical information that drives everything downstream, and doing this in a way that's not tied to having to build a 3D model to start capturing this information. That's kind of our philosophy, is doing as much as we can from the standpoint of capturing the design engineering requirements, ultimately to use that to feed the generation of models. Ultimately is where we see that going, is using this as the basis of automatic design processes. But it's all steeped in capturing more of that engineering intent and engineering requirements at earlier stages. And then the last one here, these are at various stages, but a bit bigger picture things, longer term in some of them. And the first one is rationalizing design and fabrication part behavior. So we have design pipe, fabrication pipe. There's a lot of functionality that exists on the fabrication elements that designers tend to want to be able to take advantage of, but they're kind of shy away because they're called the fabrication elements. and vice versa. There's functionality on the design side that doesn't come through on the fabrication side, and key one of those is the flow information. So that's one of the things that's in the preview release now is getting that flow to propagate through fabrication networks. And so you can see where that leads into other analytical capabilities and maintaining that engineering data throughout the process. So that's one example of a place that we're looking to harmonize these components. And it's just going to be an ongoing area of continuing to bring those things together. Kind of similar in that vein is the content library and data management consolidation. So you might have seen things related to what we're calling presently the Fabrication Data Manager technical preview. But as we've been developing that and looking at these needs to integrate and combine technologies, we're also seeing other areas of overlap. So for example, Revit has a repository of fluid information and material information, and fabrication has its own set of the same types of information. So ultimately what we want to do is again, harmonize that into one common place of managing all that information in a common place. And then the last one on there is support for non-2D, 3D system representations. So again, this is the tying into that, what we've been working on related to capturing more of that engineering information up front. We've been capturing the data. So, the mechanical equipment, the system zones, the electrical area-based loads, the electrical analytical distribution, all those sorts of things in a tree type structure, if you're familiar with that, those functionalities in the system browser. But a tree structure isn't typically how an engineer wants to share and what their deliverables are. They're one-line diagrams and risers and those sorts of things. And so what we're working towards here is the foundation of being able to start representing other types of data within the Revit environment that isn't necessarily native to the Revit code base. So being able to present other types of views and those sorts of information in an integrated way. So one example of that, you might be familiar with our partnership with Schneider Electric and their new tool set that provides ways to represent a lot of this information as a key line diagram or one line or risers, so on and so forth. So ultimately what we're trying to do is make it where those types of views, where other partner applications can feel very cohesive within the Revit environment, because it's not just electrical, it's mechanical, it's across all disciplines. And then also what you find is in different geos, they have different requirements, different representations, so on and so forth. And so instead of trying to figure out and tackle every geo's kind of way of doing things, what we're trying to do is make it where we could connect into kind of best of class applications, best of class partners that have existing IP, but then you do it in a way that feels very tightly integrated into kind of the Revit environment, but also the Revit data model. So that is the last slide I have. So I'm gonna, actually I'll go back to the one that has, I'll just leave it on this last one since you have, so you'll have the link and I'll switch over to kind of the questions.
Sounds good. And it looks like Bob was kind of thinking along ahead of you before you talked about the electrical. He asked, this is Bob Bell, where are we with the need to circuit electrical data cross-linked models?
Yeah, so this is not a need that's unique to electrical. There's a lot of cases where data needs to kind of be shared across models, electrical data, mechanical to electrical, architectural to structural to fabricators, so on and so forth. So there's investments going on generally within Autodesk around just cloud data representations and granular data and those sorts of things. We're also evolving the way that we're trying to capture the electrical analytical information. So it's not something that it's on our radar per se, but it's kind of top of mind as we're working on these things, so that we could come up with solutions for kind of more scalable ways of working. So it's, like I said, it's not on the roadmap presently, but it is something that is how we're thinking about trying to get to a point of scalable, not just for electrical, but kind of across the board.
Excellent. We have one from Jason. He asked this in the computational AMA, but was told he should ask it here. Is there any plan to create any generative or computational design workflows for MEP family placement, like lighting fixtures, air terminals, and various equipment similar to what is currently available?
I'm not sure what's meant by similar to what's currently available, but no, we're not building anything around like automatic layout of lighting based on like say distribution requirements or airflow requirements of air terminals and those sorts of things. We provide Dynamo, we provide API. We're trying to capture the core engineering information and then providing the ability to have those things automated. But at this point in time, we don't have things on our roadmap specifically around then using that information to generate layouts or routings or those sorts of things at present.
We've got Jason adding on to Bob's question. When copying monitoring MEP families, is there discussion or work being done on the parametric information to update as well, like electrical data and other parameters that may change throughout the design process? Currently, if that info changes, they have to be recopied.
Yeah, so again, no, nothing specifically related to that at present. Again, this kind of feeds into kind of having a more robust kind of common source of truth in a cloud data model. So it ultimately shouldn't become a matter of copying and so forth data from place to place. It should be, referencing information from a common source of truth. And again, it's not a simple thing to do kind of across all disciplines and types of parts and those sorts of things, but that's kind of the underlying way of that we're trying to think about going in that direction from the standpoint of not solving it in a specific domain or a discipline, but solve it in a general way and then be able to hook into that across all disciplines and domains.
Thanks, Martin. All right, let's go to Andrew's question. Could you advise on improvements to cable tray and conduit system families? There's a big lack of functionality to present cable trays and conduits. Ability to apply clearance zone to cable trays, construction sizing of trays, create system types similar to how pipes and ducts.
So with regard to cable trays, so this is one of those where harmonizing the way that design and fabrication work might actually provide something that you need now that you might be a bit hesitant to jump into. So with the fabrication cable tray components, you can use those. You could define the actual dimension versus the nominal dimension. That's one of the limitations of cable tray, the design elements that have been in there for a very long time, is that you define the size of 12 by 4 or 300 by 600 or whatever the dimension might be, and that's nominal, but it's also actual within Revit. Whereas the fabrication elements, they provide that latitude to provide actual versus nominal. And then they also have more flexibility from the standpoint of like being able to place them vertically on walls and those sorts of things. So we're trying to get to the point where those are easier to use. It's easier, more approachable, those sorts of things, instead of trying to kind of reinvent the wheel on the parts as they exist today.
I guess somebody asked a follow-up. I think it was answered by David in the chat with a link to it, but this is from Thomas. Are these Schneider electric tools a separate product we have to buy?
They are. It's a separate, it's a partner application. I'm sorry, I don't have the URL to provide more information about it. But yeah, it is a separate, like a lot of, partner applications. It is additional value and capability that is a separate subscription.
Excellent. Just a reminder, if you have more questions, throw them in the slide. We have 3 in there. Right, we have from Jason. Why is the focus the last 4 to 5 years been focused on fabrication when there are plenty of improvements? See forums that can be worked on. The MEP design features improvements have been very lackluster in recent versions.
Yeah, so good question. So it's a matter of different areas of investment. So our design investments have been around kind of the analytical side of things, being able to capture kind of the core root engineering data and those sorts of things. With regard to solving kind of detailed modeling problems and representations of components, our focus has been on fabrication because that's where we have the kind of most fidelity. We can take detailed fabrication elements and make them simpler, right? We can make fabrication elements that have, generic connectors, that have, simplified geometry, those sorts of things. But conversely, we can't take the routing logic and the routing code that we have on the design parts and make them understand coupling and connectivity and those sorts of things without kind of completely reinventing the wheel around those things. So the investments are, how do we bring these things together to make it easier for you to utilize the parts that have the level of capability and fidelity that you need. And so, we see a lot of functionality on the fabrication elements, just, some of them like being able to include installation automatically, being able to route at an angle according to a catalog, as a couple of examples of where things that we commonly hear designers want to be able to do on the design elements that already exist on the fabrication elements, not to mention things like, appropriate behavior on flanges and those sorts of things. So ultimately, like I said, we're trying to bring these things together to make it where, ultimately, in my mind, you shouldn't care which one you're using from the standpoint of a pipe fitting is a pipe fitting. And what we want to do is harmonize those worlds together so that the parts that, make sense to be as RFA, whether, it's a valve or damper or other types of components, that they can live well and play well and work cohesively in the detailed environment with the fabrication element. So that's kind of the big purpose behind that is focusing on the things that will get us to the end of the design process and installation process, and trying to feed that backwards into being able to support the other types of kind of modeling capabilities and analytical information throughout the process.
Great. So we have another from Jason. Can you speak more on the non-2D, 3D system representation? Like what kind of families would they be, and have anything we can look at?
Again, I think the biggest example would be, look at the way that the Schneider Electric tools work. I mean, it's not necessarily a family. It's more a way of being able to visualize data in other ways. So, as per the image there on the screen, it's, that's just a riser. It could be a hydronic riser, a mechanical riser, an electrical riser. I'm not exactly sure what the image was originally. But the idea being that data is already captured in Revit at the analytical representation, right? The new analytical electrical distribution or the mechanical systems analysis has these relationships established. And so the idea being that there's other tools out there on the market that then can show that same data in other ways, show it as a riser, show it as a one line. And what we want to do is being able to bring those views into a cohesive workflow within the Revit environment. So as an example, today, if you have like a third-party application, for example, and it shows a one line, and you select a thing in that one line, where you're just selecting a thing in that application. What we want to do is provide integrated experiences where that thing, potentially it's a view that you could place on a sheet, or potentially it's an element where you select the riser or the bus or the element representing a panel or whatever within that partner tool, but it's also at the same time selecting the thing within the Revit model. So if you're modifying a property, it's being updated in that central representation. So that's kind of the big concept behind it is provide ways for Revit to kind of represent, visualize, and show information in other ways that are driven by code that's actually run external to kind of the Revit core.
Excellent. I'm just going to share a link here because it's been a common theme throughout the sessions about where do they go, where does a customer go that wants to test some of the future stuff or discuss some of this future stuff. So you got the ideas board, you've got this roadmap, and you've got the feedback community, which is where the Revit Futures are located. So it's a great place for Revit testing and discussions.
Yep, absolutely.
All right, Bob's got one for us. Related to Andrew's question on conduit, the multiple conduit tool is fine for initial app, but heaven forbid there is a design change. Any thoughts on improvement?
Yeah, again, this is kind of steeped in capturing more of the analytical information and engineering data to be able to automate these things and help facilitate change. So, one of the things that is related again to the analytical representation is, at very early stages of design, right? When that you just say have a switchboard and off that is a feeder to a chiller or to another panel. Well, at that point in time, you already know that you have a feeder. You already likely know the size, like is that chiller, is that sub panel, is it 400 amps? Is it a chiller with a 200 amp feed to it, right? And at that stage, you already know the conduit size, your wire size. The only thing that you haven't accounted for yet at that conceptual stage is there a consideration for voltage drop that will upsize that potentially. So the idea being able to capture kind of more of that feeder information at earlier stages as part of the analytical representation, so that when change happens and something moves, that you're not dependent on the 3D model retaining all that connectivity and logic. You've captured the design information engineering-wise, analytically as data, and then the 3D geometry essentially is kind of the manifestation of that. And so by connecting those two worlds and providing kind of the underlying data, we believe that out of that can come automation. But it takes obviously it'll take time for us to get to the point where we have more and more of that data that could feed into those processes available.
We have a question from Mark Decker. Very interested in replacing plant 3D workflows, one lines, ISOs, models, and Revit. Is process mechanical part of the conversation of content management, data management, and single lines?
It certainly could be. I mean, ultimately, where we're going with this support for non-2D, 3D is it could be any kind of visualize data of any sort. We don't have anything specifically for ISOs or one lines on our Revit roadmap presently, but generally that's the idea, is being able to expand the platform from the capability of being able to represent other types of data in other places. I wouldn't say that we're looking at having Revit generate its own ISOs and those sorts of things. There's other technologies out there that can be connected to, shared data with, and so forth. But ultimately, that's what it boils down to, is how do we provide the frameworks to be able to provide access and connected workflows to different types of data and different types of applications that already provide very robust features sets in those areas.
Excellent. Andrew Eaton asks, will global electrical standards be made available to Revit electrical analysis? Presently, only US standards are available.
I'd be actually interested in digging into this one kind of offline to understand what some of the core barriers are. I mean, we're certainly aware of some of them, but what we're ultimately endeavoring to do is make it where if you're familiar with the demand factor functionality, those are all kind of hardwired, right? I mean, there are options and there are settings and there are tables and so forth, but they work in a certain way, right? There's a certain set of rules that we support. Ultimately, what we want to be able to do is provide that as a more open framework. So as an example of that, on the mechanical pressure drop functionality, we have different ways to replace the way that the friction loss is computed. And so we kind of have in mind similar ways of doing that on the electrical side, where you're able to capture the core data. That data can then be operated in ways that are driven again by external code that isn't necessarily code that we write. It might be stuff that Schneider brings to the table as part of their global reach. It might be other tools that are able to plug in. Ultimately, what we're trying to do is provide a more open foundation to provide that type of flexibility, and then on top of that, see how we start providing more of that flexibility. And like I said, we're aware of some of the kind of specific needs that are on the radar and some of the other geos that we know we need to be able to support from the standpoint of, like, here's some base examples of where we need flexibility to be able to compute in ways that we can't today. But I would be interested, like, if you put something on Revit Ideas and tag me on it of specific examples, that way we could consider what those platform needs are ultimately.
Thanks, Martin, for that last end of that. I was going to ask you where it would be best to follow up on that you would get it. And they could also do it on the roadmap, but ideas and tagging, you would be a great way for that. All right. It's Jan or Jan, probably Jan. Do you have a clear picture of what you want to solve through plain Revit as opposed to relying on third-party solutions used largely in many markets like the Nordics? Examples, MagicCAD, SysQ, etc. Yeah, it's an interesting question. So certainly there's certain things like a lot of third-party tools, they provide like modeling enhancements or reducing your picks and clicks and those sorts of things. So that's one of the areas where we're not looking at necessarily always trying to focus on optimizing the picks and clicks. We're trying to optimize for the big picture, right? And so again, that's where trying to connect these stages and connect the data, right? That's not about picks and clicks. That's about big picture, kind of across the spectrum type thinking and investments. But then other tools like MagicCAD and others like that, they have great libraries of content, but then also they provide geo-specific capabilities, right? So like there might be certain ways that sprinklers, for an example, get detailed in the Nordics that are unique there, or the way that they're represented, or the way that they need to be laid out, or those sorts of things. So again, partners, we see them as providing kind of that locale or geo-specific kind of capabilities, and a lot of times we also see them doing things like modeling optimization type things. What we're trying to do is provide the foundation of the data, provide the environments, and then provide the frameworks to provide the opportunity for those types of automations. We have another Martin. Uh-oh. Yeah. Were you in there to submit a question? Anyway, the question is, what is the current state of being able to smoothly take the MEP model into digital twin software or a service such as Tandem? Yeah, sorry, I can't answer that because I don't know I'm familiar with kind of the concept, but I don't know, I don't know if there's API barriers. I don't know
if it's a data model thing. I'm not sure what issues that you're running into. So I just don't know enough about like what the challenges might be to address that and what would make it smoother.
Excellent. Well, that might be another thing to throw into the ideas and tag you if
Could be.
there's something, and then that discussion would be had between Tandem and the Revit team. Mr. Bell, future phase. I understand why we don't want all elements in a future phase to be graphically visible / overridden, but I'd sure like some way to handle display calculation of future elements in the box versus custom parameters filters.
Yeah, this actually, I was having a conversation with one of my colleagues, like right at the start of the year on kind of this topic. And, we've alluded to kind of the idea of this cloud information model and different ways of connecting data. And the way that I think that's kind of percolated in my mind around this is, and also from a software architecture standpoint, is that Revit today doesn't have a way to represent different values on the same thing at different phases, right? And that's really the crux of the problem from an electrical perspective, in that an element could be on different circuits at different stages. It could have different loads at different stages. The circuits can have different loads at different stages. The circuits could be connected to different panels at different stages, and the panels' total loads could be different at different phases and so forth. And so ultimately, I think this is really more of a data coordination problem, where we ultimately might actually need to like synchronize multiple models in a way where, all right, you have your base model, and then a transparent, well-developed experience where the changes are actually in a separate Revit model, so that separate Revit model can maintain those individual parameters. And then, if you need to demo things, add things, remove things, that all happens. And if there's another stage, then there's another synchronized model. So I think that's ultimately how this needs to be solved. And some of the core enabling technologies from that are, on the horizon, but it's certainly not a simple problem to solve across all stages. But I think that's, like in my current thinking, I think that's the path forward of how that becomes an approachable problem. As you might know, like one of the challenges for a long time has been just phasing visibility representation in Revit. That was one of the improvements in 2023, was finally getting it where demolishing duct and pipe and so forth, didn't lose the system information. It now maintains connectivity, so you still get the sticky movement and those sorts of things. And we were trying to be pretty clear that that wasn't solving the computation problem from phase to phase. Which is what I think this is highlighting, is how do we solve that computation problem from phase to phase? And I think, ultimately it boils down to how do we synchronize these different stages across different models at different phases in a way that's like, well orchestrated and not a, doesn't become a manual maintenance nightmare like it is today, but something that, is facilitated by these enabling technologies.
Yeah, like Robert and Chad agreed with you. The other is dovetails into this, is from Jason. We've had some issues with the new demolished MEP elements workflow, where new duct, when routed through where a demo duct, it would connect to the demo duct. Has anybody experienced that?
Yeah, I think so. I think what you're alluding to was something that was addressed in the 0.1 release. So which has been out for, I don't know, maybe a month or so, but the 23.1 release, there was an improvement around not having it connect to things. And I believe that this is exactly the case. If it hasn't been solved in that, we would certainly want to, know the scenario that you're running into where that hasn't been solved.
Another one from Jason. This was discussed in the AEC, so this would be the Revit AMA. But do you have any plans to add more categories with buttons / keyboard shortcuts like the 2023 Elite release, or no buttons like the 2022 categories that are easily added to the model, especially for new users like fire protection and audio visual devices?
I'm not sure I completely understand the question. Audiovisual and fire protection devices have been there for a while. We added mechanical control. I forget exactly the category, mechanical control devices or something along those lines. There is a button on the ribbon for those. There was also the new plumbing equipment category, so there's a button for those. I'm not aware of other MEP categories that we didn't provide a button for. As far as adding more categories, no plans at present, nothing on the roadmap. I'd be curious to understand like what you're looking for that's not there.
He followed up with continued, both those categories should be MEP, not architectural. So maybe those categories were under the architectural. I don't know.
Yeah, the ones I'm thinking of were the fire alarm, like the fire alarm devices, audiovisual devices, which are under electrical. If it's something different, I'm not clear. I'm not sure what it would be. So if you could clarify, that'd be good.
Yeah, he said in the chat, AV and fire protection should be MEP categories. But you're saying they are, right?
Yeah, I must be thinking about something different. I'm not sure. Maybe if there's if you have a reference to the help or something to help me understand, but I'm not sure. Sorry.
Thanks, Martin. Bob had another question. I haven't checked, so forgive my asking. Did the newer object style categories get added to the appropriate discipline filters? Example, when the AV category was introduced, it didn't fall in the electrical filter when filtering the object style dialog.
Yeah, I don't know. If these were added by unfortunately, I'm only familiar with the ones that my team specifically added, and those were the teams that I work with were the mechanical control devices, and then like I said, the plumbing equipment. If there were other categories and they somehow behaving consistently in some way, I mean, it's possible. I'm just not familiar with it. So, I'm happy to try to understand better, but I'll need more information because I'm not exactly sure, which categories these are and where they show up and so forth. So I apologize, but I'll try to understand that better by, maybe reading the documentation after this seminar. So.
Thanks. Make sure you get your questions in. We're on the last one here. This is from Jason. In addition to the future phase, how about data connectivity across design options?
Yeah, that might also be related to kind of the need to maintain data across multiple models, because ultimately design options, that's going to require different computations being kind of persisted at the same time in some way, or constant recomputation. It's not something that's presently on the roadmap, but we believe that kind of some of these enabling technologies over time might make some of these things possible, but it's not something that's presently on the roadmap specifically.
All right, well, let's see, that's all the questions. So get a question in there. If not, we'll wrap up here soon. So
yeah, I see Bob said, we'll open a support ticket on those other categories. That's great.
Oh, here they come. Just that fast. From Bob, room space coordination. What a pain. Design options, phases, etc. Any hope?
Yeah, maybe. Like I said, some of these enabling technologies might be the path forward, but again, nothing specifically on the roadmap. Is building a tool to model slope duct a major coding challenges? It's got its complexities for sure, because ultimately it boils down to how are they going to be manufactured in our kind of area of responsibility of supporting kind of design to make. When you have particularly rectangular slope duct, there's different ways that you make that connection. You can't just take a regular rectangular elbow and a regular straight and smash those things together and say it's now sloped. It requires modification of the flat pattern development to make that work. So to really have a design to make workflow for slope duct, yeah, there are. If it was easy, we would have done it, I guess is another way to say it. It's not a simple problem to solve. And rectangular duct just makes it even more complex than just dealing with, say, sloped piping and so forth.
Yeah, you made Robert laugh in the chat. We'll give a few seconds here and then start wrapping up. We don't have any in the queue. We've got Andrew in chat. We'll take that as an exception. We want to keep everything in Slido so that we can address all the questions that were answered in the in the event. Oh, actually, we'll take you on. Andrew, if you could throw yours to the Slido, that would really help so we can track all the questions that were answered in this session. So Jan had large scope system management can be a pain in Revit. Do you have improvements in mind when it comes to multi-system pipe or duct drawing? Examples, hot water, cold water, circuits, dealing with many systems before connecting them, etc.
Yeah, I mean, this exactly gets to that point, early on in the conversation around embedding more of that design system requirement earlier at the design stages, right? Because again, conceptually, when you're starting to think about your mechanical system or your plumbing system or whatever the case may be, like, you have a chiller that's connected to a number of air handlers, and you might have another chiller in a different part of the building, or just serving different areas, or just the way that those are all interconnected. Those are design decisions that persist from the conceptual stage all the way through the detailed design stage. And today, the way that Revit works is it expects you to create ultimately a physical model to represent the design intent. And I kind of jokingly say that, like, system browser is something that you have to manage instead of it helping you manage, right? It kind of works that way, that, like, it shows you the data, but it doesn't really help you manage it. So again, this is where kind of capturing that upfront systems analysis stuff conceptually, get that in structured data, make sure that those data structures are something that then the physical model then manifests it, instead of the other way around of relying on you to create the physical model in the right way, in the right order, and connects things in just the right way, and then expect out of that Revit to understand what you intended from the analytical intent. So again, that's why we're starting with all that analytical stuff up front, is to kind of rein in the kind of system logic, if you will, of how Revit understands the world, have that steeped in kind of good design concepts and those sorts of things, and then use that to drive and validate against the physical model instead of the other way around.
All right, Bob Bell, is there anything on element representation on slope surfaces? Example, lighting fixtures on a slope ceiling. Nested annotation families don't show.
Is that so? Actually, I was talking with a colleague about this yesterday. There were some changes in 23, but I don't recall if this solves that issue. I know that when I was playing with it yesterday or earlier this week, I was placing a receptacle on a sloped wall, and the symbol did show on the sloped wall, but also did the 3D geometry. So I don't think it meets, like, the needs. We don't have any definitive plans, but it might be areas now that some of those functionalities are in place that we can fine tune. So if you can kind of share more details about examples and those sorts of things. Like I said, there were some changes in 2023 that might have addressed some of this, but I'm aware of cases where it didn't go quite far enough. And so if you provide kind of more details, we can kind of see what we can do, and perhaps chase it a bit internally and see what we can do.
Yeah, Jason responded as well in the chat and said, Bob, for those slope lighting fixtures, I created an adaptive element with nested and shared lighting fixture family. It works for what it is. So we've got a question from Andrew Eaton. Could you look at developing a view template filter manager to be able to push and manage filters across multiple view templates?
I would say something like this should go on the ideas. It doesn't sound like an MEP specific thing, but it could be an idea station thing for sure. My guess is generally it's, there's probably all sorts of things that people would want to be able to push manage across multiple view templates, not just view filters, but line type styles and so on and so forth. I mean, I certainly see an opportunity for general style management across models, whether they're templates or models in flight or those sorts of things, but I'm not aware of any current plans around any of that.
Excellent. I gave a link in the chat to the ideas so that anybody can throw their ideas in there. Samir had a question. Passing information across models should include connector family data in linked models.
Connector family data. Yeah, I think generally Samir's just kind of alluding to the need to kind of share that analytical information across, more than just the kind of host Revit model, so to speak.
Right. We've got 2 left here, and then we'll wrap up because we are going to come up against the hour here. And I'm sure, Martin, your voice is going to start going hoarse pretty soon. I sure appreciate all the great detailed answers and all the great questions from the attendees. Jason, I would like to add to Andrew's chat question. What about seeing what view templates a particular filter is being used with some sort of view template? So this is back to the same one. This would be
we tag each other on ideas on if these are related things, and elaborate there.
Yeah. Shaan asked, does support for 2D systems include P&IDs, and does that mean P&ID modeler is unsupported?
It could mean support for it is 2D systems is kind of any representation is ultimately the plan of, any data that can be connected to a Revit model should be, we envision all types of data that can be represented in there. We don't, P&ID modeler, it's not unsupported. I mean, it's a feature of Revit, it does what it does. We don't have plans presently to add to those capabilities. Instead, we're looking at kind of these more generalized solutions that aren't point to point, single application to single application solutions. We're looking at kind of generalizing frameworks and technologies to provide general frameworks around how we can scale that to all sorts of products and domains and those sorts of things.
All right, I'm going to close the questions now. We're coming up on time. I see a comment from Robert or Bob Bell. I go way back with Bob. He said he was glad he was able to attend. Miss you guys. So I'm sure that's a whole family of Autodeskers missing. So,
yeah, I share that sentiment. Thanks everybody for attending today. It's always great to get these questions and to see what's top of mind and what you're thinking about. And it's just as much informative as in a lot of cases it's validating about the way that we're thinking about those things. And so we always, like we say, feedback is a gift. We're always looking forward to it more. And like I said, let's take a look at the things on the roadmap. And if there's any there that you're particularly passionate about, we're always looking to get people involved in research and sprint demos and those sorts of things. So yeah, don't take this as a one-time event necessarily.
Absolutely, totally agree with that. I got a few links here. If we can go to the next one, we do have some great community conversations that are scheduled, including some Revit ones. If anybody would like to share their expert knowledge or have a panel discussion on MEP or anything else, we're always open to those. On the community conversations page, there's a Get Involved tab. It'll tell you about what we're looking for and how to submit that and get you on the calendar. Some links here. You got the forums, of course. The Community Voices is by the community. So if you want to blog, you can request to be a blogger and author posts on MEP. We'd love to have you. We have a lot of Revit and Inventor and all those different customers providing their voices and expertise. And it's great. And then the Community Journal is from the community team. And yeah, don't forget the next community conversations. A lot of good sessions out there. And I appreciate everybody's participating. Martin, thank you. This was really great and helpful, I'm sure. And thanks to David in the background, David Smolker, appreciate that. And we're missing Kimberly. I hope everything's fine with her. And anyway, stay tuned, stay in touch, and keep involved in the community, everybody.
Yeah, thanks everyone.
Thank you.